Hey guys, this is going to be a nice short video, kind of just highlighting some of these things that might seem confusing just on a first read, and a couple other things that I noticed were on the questions that weren't on this summary page at all. So, I know I talked about this yesterday, I just want to point out a few, I guess, kind of key ideas, is that, remember, absolute zero, we call it absolute zero for a reason. It is the actual absence of thermal energy, the absence of vibrational temperature, so the particles would actually stop moving. Okay, remember there's nothing colder than not moving if we're going off this idea that temperature is a measure of movement. Okay, so second section is where we're going to spend most of our time here, and this is the first law of thermodynamics, and this is really just a kind of more specific way to think about this one, which I believe we have talked about on a number of occasions, the law of conservation of energy, okay? Which was, remember, all of our laws of conservation just mean that something is not created or destroyed. It can just be kind of moved around. It can change form, but we're not really making it or destroying it. And so that's the same idea, but when written as the first law of thermodynamics, we're going to zero in on kind of the heat thermal energy aspect of this. So it says, first law of thermodynamics says, whenever heat is added to a system, it transforms to an equal amount of some other form of energy. So I wanted to kind of talk about what do we mean when we say a system. Okay, a system is everything we are looking at. Okay, and I would say the system is versus literally everything else in the universe. Okay, so think about that for a second. So it's the system versus everything else. So I'm saying if I add heat to my system, let's say my system is my Pop-Tart and its sleeve and the plate in the microwave. Okay, so if I said my system is the Hot Pocket and the sleeve and the plate, then everything else in the universe I would describe as being outside the system. Okay, so that includes the microwave. So heat is added to a system, then it's taking that heat from somewhere else, right? So if energy of the system increases, this energy of literally everything else in the universe is decreasing, right? It's a transfer of energy from everything else to my system, to my area that I'm talking about, my things that I'm looking at, my whatever I'm interested in for the purposes of that problem. Okay. They describe it as a group of atoms, particles, or objects, but, you know, that's very, very vague. It's whatever that you are talking about for your problem. Okay. And kind of want to talk about this bullet point. Energy is added to a system does one of two things. It increases the internal energy of the system. So basically, if I'm taking energy from out here and putting it into my system, then that system is going to have more energy. Okay, so that's option one, increase in the internal energy of the system. Or, two, does external work if it leaves the system. So that's saying I take some energy from out here, I add it to my system, and as soon as it gets into my system, it leaves, and it does work on something else. Okay, so think about, you know, maybe if my system was a pulley. Okay, so my system is just the pulley. If that's my system that I'm defining here, because I'm going to add energy to my pulley system by pulling down on it, and as I pull down on it, my pulley is immediately going to transfer that energy to whatever it's lifting. Okay, so it can do two things, and actually kind of take it in and store the energy, or it can immediately use it to do work. Okay, so we can always try to make everything into an equation in this class. So the amount of heat that was added to our system is going to equal the amount of energy that it keeps, right? The increase in internal energy plus any work that it does. So if I take the amount of energy that it took in and kept, plus the amount of energy that it expelled by doing work, that's going to equal the amount of energy that it took in from heat. And this is just another kind of way to think about this. If work is done on a system, the system's energy will increase. If work is done by the system's internal energy will decrease. So again, this makes sense. If I am, eating food, I am taking in energy. Remember, work and energy are kind of the same. Work is just a way to think about the movement of energy. So if I eat a bunch, I'm taking in food. I will have more energy than I had before. If I am doing work, I'm, lifting weights or running or just going about my day, moving my body around, I'm doing work if my system is my body, and I will have less energy left over. Okay, so hopefully that concept makes a little bit of sense. So we had this worksheet in our my materials, this guy, and we've done ones like that before, but instead of actually having you try to either write it out on paper and take a picture or whatever, I just typed out all of those questions into a Google Doc, which is what is attached here. For the most part, you're going to be able to find all the questions pretty straightforward right here, and there's just those two sections. Some of them you're going to have to think here and use your brain just a little bit, but I don't think you will struggle too terribly much. As always, let me know if you need any help. That's it for today.